This is Holy Cross Component 1 mock, and it's mock number 3. Question 6. The student monitored the growth of population of yeast cells. You've met yeast in a few experiments in a culture flask. 2-hour intervals, number of cells growing in the flask were determined, and we've got a table of results. Age of culture in hours versus number of cells. Oh, don't you just love it? Plot a graph. Right. 4 marks for plotting this graph, and the marks are usually, right, have we come up with our correct axes? We've got these the right way round. We've got our correct axes labels that we'll just copy straight from the table. And is this scale sensible, like we've used over half the scale in each direction? Have we put our x's in the right place for plotting, and then have we drawn the curved line, which I'm going to do dot to dot with the ruler. So those will be the 4 marks there. You'll do this with a pencil, a sharp HB pencil, so you can rub out mistakes. I'll do it with a red pen just to make it stand out. Hopefully I don't make too many mistakes. Choosing a scale. Right, along the bottom we're going to have our age of culture. And we've got to go up to a maximum of 20. And how do we choose a scale? Well, if we just did 1 square for 1 hour, what would it do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we had 1 square per hour, it would come up to there. Well, if we doubled that, it would come up to there. And are we using more than half? Yes. So we'll go for that. So I'm going to go, so we're starting off at 0, and then we have got every hour will be 2 squares. Maybe you've watched the math skills videos. Some of them very tedious watching me draw graphs. So that'd be 1. So we've got 2 hours there. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we're using more than half of the grid. The label for that, well, I'm just going to copy the label that we've got. So that is age of culture in hours. If you don't copy that straight from there, then you're crazy. And up the side, what's our number of cells got to go up to? 690. So if we call it 700, what would happen if we had, say, let's choose an easy scale, 10 squares is 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If that was 100, can we fit 7 of them on? Yeah, I think so. So that'll do for that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this will give us a nice regular scale that we can put odd numbers on if we need to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again we've got 0 there, 100, 200, 300, 400, 500, 600, 700. We're going to copy the axis title, number of cells times by 10 to the 5. Okay, right, let's plot. So 0 hours, we've got 1. So there's our, so we're right down there. 2, we've got 4. Again, hardly registering on this. So less than half a square. At 4, we've got 30. 10, 20, 30. This is where you're glad that you've drawn a reasonable, sensible scale. At 6, we've got 68. 1, 2, 3, 4, 5, 6, and then nearly to the next one. At 8, we've got 240. So there's 200, 10, 20, 30, 40. A lot of work for 4 marks, isn't it? 10, we've got 450. So 10, 4, 10, 20, 30, 40, 50. 12, we've got 610. I can't see where the lines are. 12, there we are. We've got 610. 14, we've got 680. 700, 680, and 16, we've got 690. So 1 less than 700. And 18, 688. So 18, six, 8, 8, so just under 690, and at 20 we have actually got 690. So there's our plotted points. I'm going to join these up just dot to dot with the ruler, and unless it gives you any instructions not to do that or to do a curved line, then you're much better off just doing this. Try and get it from the center of a point to the center of a point. So even though this is a lot of work for 4 marks, it's not overly taxing. You know, you should, with a bit of time, get these marks. You might as well have them as not have them. So still being careful to join them middle to middle. Right, there we go. One graph. How many yeast cells were present at 7 hours? So at 7 hours, you could just read this off, but you're probably better off putting your pencil on and drawing a line from 7 hours up. So at 7 hours, I'm going for 110, 20, 30, 40, 50. So 150. But the answer's not 150, it's 150 with our units. So 150 times by 10 to the 5. We got to say that. What was the carrying capacity of this culture? Well, that was the maximum population that it can support. So that's our biggest number there, which is 690 times 10 to the 5. Why the population leveled off at a steady rate. So, why didn't it increase any further? Well, the usual answers there, about nutrients running out, competition between yeast cells, toxins, that sort of thing. So, reduced levels of nutrients, accumulation of toxins, which in this case would be ethanol, the byproduct, which you've just talked about in the previous question actually. We could say we could say not really competition, because there's no other yeast cells there, but number of the dying cells equals the number of the cells that are being produced by budding. But those are the two main things you're gonna say. With reference to the graph, identify each of the phases between 0 and 6 hours. So what's this phase down here? You should be fine with a lag phase there. And 8 to 14, that's our steep phase. You should be fine with exponential, or you might have said log, but exponential is better there. If the culture was left for another 20 hours, so right over here, what would happen to the yeast population? And we'd have a death phase, the last stage, so it would decline. So it would be a steep decline in numbers. So apart from a tricky graph to draw, the rest of it was pretty straightforward. These two here depended on your graph as well. So even though you just thought it was 4 marks for a graph, you couldn't really do the next two without a decent graph. So it's worth practicing those graph skills.